Hi, this is Algebra 1, Lesson 64. We're starting on page 260, and we're going to talk about domain and the addition property of inequalities. In problems in math and math-based sciences like physics and chemistry, the numbers that we use to substitute for variables are often restricted by the nature of the problem or by a restriction stated in the problem. For instance, if a person goes to the store with 25 cents to buy eggs, and the eggs cost 10 cents each, the total amount of money that can be spent on an egg can be written in an equation like this. The total cost equals 10, that's 10 cents, times the number of eggs bought. The customer may buy 0 eggs, 1 egg, or 2 eggs. If the customer buys 0 eggs, then the formula looks like this. 10 times 0 eggs. And so they spent 0 cents. If they bought 1 egg, then it's 10 cents times 1 egg. And so the cost is 10 cents. If they bought 2 eggs, then it's 10 times 2 eggs. So they spent 20 cents. We cannot use 3 as a substitute because the customer only has 25 cents. We can't use 2.5 because nobody sells half an egg. We couldn't use -4 because buying -4 eggs doesn't make any sense. We are restricted by the problem to only using 0, 1, or 2 as substitutes in the equation. The set of possible replacement values for the variables in a particular equation or inequality is called the domain for that equation or inequality. We're going to use a capital D for the domain and indicate that they are sets by enclosing them in braces. So the domain for that problem was domain equals the set of 0, 1, and 2. This would be the domain is all real numbers, or the domain is positive integers. Okay, so here's an example. Graph x is not greater than or equal than 3, and the domain can be any integers. So integers are whole numbers and they're negatives, and this is an is not greater than or equal to. So it's not going to be greater than 3, it's not going to be equal to 3, and it is going to be an integer. So it can be a 2, or a 1, or a 0, or a -1, or a -2, or a -3, and so on and so forth. So when we're doing this kind of inequality, you're going to make the arrow bigger. A different color is a nice thing just because it stands out, to say that this pattern continues on into infinity. So let's graph x is greater than 2, and the domain is all real numbers. Now it could be halves or decimals or anything. So x is greater than 2, it does not equal 2, so we put a circle here, not a dot, and we're going to make the arrow go this way. Now we're going to graph x is less than -1, and the domain is all positive integers. So if x is less than -1 and the domain is all positive integers, there's no answer to this. The answer is actually an empty set. There are no numbers that match these requirements. Okay, graph x is greater than or equal to -5, and the domain is all positive integers. So here's -5. It could be greater than or equal to -5, but it's positive integers, so we can't start putting our dots in until we get to 1. And then all positive integers are in the possible solution set. Okay? Now we're going to talk about the additive property of equality. If a, b, and c are real numbers, and a equals b, then a plus c equals b plus c. We've done that before. Because a plus c equals b plus c, we can add the same thing to both sides and still keep the equality. So for example, we've got x plus 4 equals 8. If x plus 4 equals 8, then we can subtract 4 from this side and subtract 4 from this side. And we know that the sides are still equal. Okay, so this what was true about equality equations are also going to be true about inequalities. If a, b, and c are real numbers and a is greater than b, then a plus c is greater than b plus c. So here we have x plus 4 is greater than 8. And we can do the same thing. We can subtract 4 from both sides, and x is going to be greater than 4. Okay? So here are some examples. We're going to graph x plus 2 is less than 0, and the domain is all real numbers. So first, let's get x all by itself. So let's subtract 2 from both sides, and we have x is less than negative 2. It's less than and not equal to, so we're going to put an open circle, and it continues that way. Okay, now we have graph x minus 3 is greater than or equal to negative 2. So let's add 3 to both sides, and x is greater than or equal to negative 2. And the domain is all the integers. So it's not going to be any of the spaces in between, so we don't want a line. We're going to do dots, and it's greater than or equal to, so this is going to be a closed dot. And we're going to continue that pattern infinitely. And that is it for this lesson. Not too hard. I think you can handle that. Try your practice problems and let me know if you have any questions. Thanks.